Alright, I've set the true mean value of my population back to 0, and now we'll ask, when we do reject the null hypothesis, what is the typical value of the mean of the sample? We'd be saying, okay, our sample mean was large enough that we're pretty sure it's not 0 compared to the standard deviation or standard error. So I'm going to reject the null and say that my sample mean is not 0. My best estimate of the sample of the population mean is that just whatever xbar I have. So what's a typical size of that xbar? So here, when the population is really has a mean of 0 and the null is 0, here we're doing an average if, saying when these things are 1, take the average of these values for the rows where these are 1. And we'll get some new random numbers here. So what would you say is the average value of x bar in the cases when we reject h null, h naught? Well, it's kind of bouncing above and below 0. It's probably going to average out to 0. Now what if I make this mean value, true population mean, 3, which is not very big compared to a true sigma value of 10. I'm still only rejecting the null roughly 5% of the time, probably a little bit higher. But look at the average value of x bar when we do reject the null. It's almost always up in the 8 or 9 range. That means on average we would think the true population mean is 8 or 9, even when it's actually only 3. So what we're seeing is inflated estimates of the population mean.